In this video I'm going to illustrate how to convert experiments that were measured using the Avantage data system using the .dth filter. And the reason I'm introducing the .th filters is because these are more recent filters that have been added to CasaXPS than the older ones, which are .vg type filters, so .avg, .dvg. These are older than the .dth filters, and these newer filters will allow you to convert the more intricate experiments that are performed on the Avantage system. The experiment that I'm going to look at involves a multipoint, a depth profile, and an iteration. And the idea is that you set up a series of measurements based on these multi-points. Each point has a different name, hopefully, and the different positions on the sample are then measured using a depth profile. In this instance it's just a very simple profile, the as received, and then following sputtering another measurement. And just to illustrate that more can happen than the one type of experiment within this multi-point environment, there's also an iteration where just the same spectra are measured without any intervention such as the ion beam. The result, when we convert the Avantage data files from the binary format into the AVG format, are a set of files that are organized in quite an intricate way, which does require the .dth filter to convert. To convert data that have been saved by Avantage after it's been converted to the .avg format, we use the import option, which says convert file, and what this will do is it places us in a directory which is part of the directory structure that has been generated by Avantage that contain the various Avantage files. So if I go down here, we can see two directories that contain the depth profile and the iteration. If I go into the depth profile, you can see that it has VGD, meaning the data files in binary format from Avantage, and the corresponding AVG files. These have been exported explicitly in preparation for the operation I'm about to perform. So if I go back up, I'm at the level of the two directories. I don't actually have to be at this level to convert these data using .dth, so I'm going to illustrate that by going to the level above and saying I'm at the multi-point experiment level in this directory structure. And if you look up here, you can see quite an extended file structure, folders containing folders, leading to this multi-point experiment. Now, one point that is worth noting is that Windows has a limit for certain processes on the length of the path names to a directory or a file. For example, in this version of Windows, I wanted to change the file extension of an AVG file to a TXT or some other file extension, and I was unable to do that in this version of Windows. It objected to the length of the file. Sometimes when you unzip a directory structure like this to a directory that is deep within some other directory structure, that too, the unzip process fails. So it's probably a good idea not to make these paths too long. Now, despite the length of this path, we can convert this multi-point experiment by using the .dth filter. So .d meaning directory, th meaning thermo. The th filters are more recent than the filters that correspond to a .dvg, for example. If it ends in vg, that's an older version of the filter. If it ends in th, that's a newer version of the filter and can cope with far more intricate experiments than the older VG filters. So I've entered .dth and I just say open. You can see a dialog window comes up. It tells me it's found two directories that contain AVG files. This is good. It matches the flowchart and it gives me an indication of where these are. Very long path, as you can see, and if I say continue, it will then convert and save to disk VAMAS files that correspond to those two directories. So the number of VAMAS files created is 2. It also looks to see if a VAMAS file already exists in the place in that directory structure that corresponds to the directory, and won't convert if it's already there. This is very specific to the thermo filters. This will not occur elsewhere, but for thermo filters it will not overwrite an existing VAMAS file. So if I say OK, I now have 2 VAMAS files. We've got the depth profile and we've got the iterations, both loaded in Casa. If I cascade, you can see both data files are here. Here's the one that would have caused problems to the older filters, the depth profile, because at each point in the process of measuring the profile, it has to move and then do a profile measurement, and the older filters would probably not enter into the VAMAS file all of the different sputter cycles. The new filter, the .dth, will. So here we have an experiment where we've got 2 measurements, one at the as received surface and one after sputtering for 60 seconds. Now what I would like to do is just have a look at the larger icon toolbar so I can switch to the different names. So each point in this multipoint has been assigned a different name, so I can see that row, these are 2 measurements from the same point. Now it's not particularly well organized at this point, so let's turn off the edit mode, and instead I'm going to use the SID toolbar button, and now I can see for each one of these points I have my profile information. First for the carbon, the 3 carbon, then there's oxygen, and whatever else has been measured. They're all organized according to the experimental variable in columns corresponding to the positions offset, albeit. So if you wanted to see just the samples that are 0.1, you could go through and indicate as I was doing there, or alternatively what I could do is I could search for and say I want to look for, let's see, it's 0.1 and it's been called hash 001. So if I now search for these, then what will happen is it's found 12 matches. So I've now got all the data from one of these points selected. I could copy that to a new file. So now I've got just from 0.1 all the data that I measured from a given point, 0.1.